Now let us go on to derive the equation of the standard ellipse. Alright, so let us recollect. The ellipse is a curve or a conic section whose eccentricity is less than 1. Right, so that means the ratio of the distance of any point on the ellipse from the focus and from the directrix, that ratio is less than 1. Okay, so here first of all, to derive, let us consider the frame of reference, that is x and y axis. We have the origin. Now let us consider some point A which lies on the ellipse. Okay, let us call that point as A, and let its coordinates be a comma 0. Then let us show the focus as S, and let us denote its coordinates as h comma 0. Okay, we don't know what that h is, we have to find it out. And let us show the directrix also as a line at some location, suitable location, that is, let's call it as say x equal to k. Right? Let us denote the point where the directrix is cutting the x axis as say M, right? And let its coordinates therefore be denoted as k comma 0. Right? Now you see, since A is a point that lies on the ellipse, clearly the ratio of the distance of A from S to the distance from A to M, that ratio must be nothing but eccentricity. So in other words, we can say that the point A divides segment SM internally in the ratio E:1. Perfect. So from this, what we can do is we can write for the coordinates of point A using the formula for internal division, right? Section formula for internal division. So therefore we can write A is given by E into K plus 1 into H, that is H, upon E plus 1. Right? So therefore that gives us AE plus A is equal to EK plus H. So we get one equation. Right? Now we can also imagine some point, in fact it will be symmetrically opposite to A, that is A dash, and that will be minus A comma 0. Okay, this point can and will also lie on the same ellipse, but such that now the ratio of its distance from S to ratio of its distance from M, this ratio will be now the eccentricity, that is E. The only difference is that here A dash will divide SM externally in the ratio E:1. Okay, so therefore we can use again the section formula for external division for the x coordinate of A dash, and therefore we get minus A is equal to E into K. Now you will have a middle sign as minus, then 1 into H, that is H, whole upon E minus 1. So therefore on cross multiplying you will get minus AE plus A is equal to EK minus H. Let's call these as equations 1 and 2. Now here if we see that if we subtract the two equations, that is, say for example from 1 we subtract 2, what happens is EK will get cancelled and similarly A will also get cancelled. So therefore that will give us 2AE is equal to 2H. So therefore we get H is equal to AE. This is a very important information because now that gives us the coordinates of the focus S in terms of the known values, that is A and E. Alright. Now we can also add the two equations so as to eliminate H and retain K, so that we will get the value of K. So on adding we will get 2A is equal to 2 times EK. So hence clearly that gives us K is equal to A by E. So it's clear that now let us show these values in the figure. What I will do is now I will write the actual coordinates of S and M. Alright, so therefore S is nothing but AE comma 0 and M is nothing but A upon E comma 0. Right. Now let us imagine some point, a general point on the ellipse. Let's call that as P. Now if this is the point and its coordinates in general can be written as x comma y. Then its distance from the focus is SP and its distance from the directrix is, let us call this as foot of perpendicular as n. So therefore Pn is its distance from the directrix. Now as per the focus directrix property, we know that SP upon Pn, that ratio is nothing but the eccentricity E, isn't it? So therefore we have SP is equal to E into Pn. Now we'll have to write the expressions for these, that is SP is the distance between S and P. So therefore that will be root of x minus AE the whole square plus y minus 0 the whole square is equal to E into root of, the Pn, this distance will be given by the formula. For that we'll have to first write the equation of the directrix, that is x minus AE equal to 0 in the general form, that's in the standard form. So this is given as x minus A upon E whole upon root of 1 square plus 0 square. We know how to find the distance of a point from the line. So therefore we get root of x minus AE the whole square plus y square is equal to, now this denominator is 1 and E being always a positive number, that can be taken inside the modulus sign. Okay, so therefore on multiplying we get EX minus A, because in the second term the E will get cancelled when it's multiplied by E. Right? Now to get rid of this square root as well as the modulus sign, we have to square both of the sides. Okay, so let us do that. So alright, let us square both of the sides. So therefore we get x square minus 2 AEX plus A square E square plus y square is equal to E square x square minus 2 AEX plus A square. Right. So 2 AEX term gets cancelled. Therefore let us collect all the terms. So therefore bringing the x square term on left side, we get 1 minus E square common times x square, then y square term as it is, and the constant terms we shift to the right, that is A square minus A square E square. So from there we can take A square common and we have 1 minus E square. And now dividing throughout by the term on the right side, that is A square into 1 minus E square, we will get x square upon A square plus y square upon A square into 1 minus E square is equal to 1. Right. Now for convenience, let us call this particular denominator as B square. Okay, so therefore we say that let B square represent the expression A square into 1 minus E square. Now we will see that A square is a positive quantity already, being a square, and since E is numerically less than 1 and of course a positive number, so 1 minus E square is also clearly a positive number. So therefore right side is always positive quantity, and which matches the requirement because the left side is supposed to be a square, that is a non-zero number, that a non-negative number, that is a positive number. Alright, so therefore finally on substituting we get the equation as x square upon A square plus y square upon B square is equal to 1. So this is the equation, the standard form of the equation of the ellipse, and the ellipse will have the shape, if you plot all those points which satisfy the condition, then the ellipse will look like this, which we call in day-to-day life as oval, the oval shape. Okay, that is in maths it is called as the ellipse, and these are the two foci, that is S and S dash. Because of the symmetry, like we consider the focus on right side, similarly you can consider the focus on left side also, and there are two directrices, one on the right and one on the left. So x is equal to A by E is the right directrix, and x is equal to minus A by E will be the left directrix. The focus on the positive side is AE comma 0. Similarly, it will have its mirror image, that is minus AE comma 0 as the left focus. Then the point, the extremity, right extremity, that we call as the vertex, and that is nothing but A comma 0. If you remember, that is what we had started off with, and again due to symmetry there will be another point located far off, that is at minus A comma 0. And the center of the ellipse is of course the origin. So this is how the equation of the standard ellipse is derived.